Hey everyone, welcome to AI Deep Hallucination. Today's question, verbatim from the real interview your agent breaks in production. What do you do first? What order do you work in? How do you trace the root cause? What the interviewer is actually testing isn't your knowledge of models, it's whether you've ever shipped an agent to production.
I've seen so many candidates fail right out of the gate. First words out of their mouth, check the logs. Traditional bugs crash loudly. LLM bugs quietly serve you wrong answers.
Right? The industry consensus is already clear. A 200 OK status code from an LLM API does not mean the feature worked. So step 1 in triage isn't checking status codes, it's bucketing.
Once you've bucketed, the dashboards you look at diverge completely. For cost and latency, you check TPM throttling, cost velocity, KV cache hit rate first. For quality, you jump straight into traces. For safety, you read the guardrail logs.
Step 2 is locating. Drill from the session id into the root agent span, then into the first failing span. That relies on OpenTelemetry's GenAI semantic conventions. The spec is now at 1.40, still in development status.
Once you're inside the span, the order matters. The first error you hit is the root cause. Hamel hammers this. Focus on noting the first failure observed in a trace, as upstream errors can cause downstream issues. Fix the root cause. Fix a whole family of symptoms.
The field order is also a fixed playbook. Look at the actual populated prompt first, then the retrieved docs, then the raw model output, then the tool call args, and finish reason last. Wrong order and surface symptoms mislead you.
Streaming chat has a massive trap. A March 2026 Anthropic SDK issue nailed it. An overloaded error should look like a 529, not a 200. The error is buried in the event body. Any caller checking status, code alone for retry decisions gets the wrong answer 100% of the time.
Exactly, deeply counterintuitive. Chain reaction. Last month's Claude Code 512K line source leak episode covered this. Claude Code ships a 90-second event level idle watchdog. Event level is off by default and needs explicit opt-in. The byte level watchdog is on by default for Anthropic API connections. And the leak source shows, if Opus fails 3 times with 529 overloaded errors, it automatically falls back to Sonnet. That's the exact defense for this trap.
Speaking of failure modes, Galileo's field guide catalogs 7, hallucination cascade, memory corruption, multi-agent communication breakdown, tool misuse, prompt injection, infinite refinement loops, and specification gaps. Everyone comes with a real case.
The scariest is tool misuse, their example. A cleanup agent interpreting delete redundant files as wiping the entire production directory. Academia has its own lens. Berkeley's mass catalogs 14 failure modes in 3 categories, complementing Galileo's enterprise view.
Then fixing. The most counterintuitive principle here. Don't build an eval first, do error analysis first. Hamel puts it bluntly, generic metrics are worse than useless. They actively impede progress.
His signature case, NurtureBoss's AI was failing 66% of the time on date handling. Error analysis revealed just 3 issues accounted for over 60% of all problems. After the fix, the date handling success rate jumped from 33% to 95%.
Langfuse codified this into 4 steps. Grab 50 to 100 diverse traces, do open coding with a binary pass, fail plus a comment at the first failure point, cluster into a taxonomy, then pivot to find the high-frequency patterns. Their own docspot's most common failure turned out to be RAG retrieval, not generation.
Reproduction matters too. LangGraph has first-class checkpoint replay. Every node's state is persisted. Anthropic's own research agent says it explicitly. Resume, don't restart. Restarting is expensive and makes users furious.
In the fixing stage, there's a pair that gets confused all the time. Kill switch and circuit breaker clears throat. Both must exist.
The engineering consensus on Reddit nails it. The kill switch has to live outside the agent's reasoning path, enforced by the orchestrator. If the agent itself decides when to stop, that's not a switch, that's wishful thinking.
Retry storms really burn money. One team had 5 retries times 10 agent iterations equals 50 retries and burned $83 overnight. Public cases run up $30,000, $47,000 disasters. Timeouts don't equal circuit breaker.
Retry parameters have a canonical formula. Marc Brooker's full jitter from the 2015 AWS architecture blog. 11 years on, still the standard.
For rollouts, Anthropic's own practice is called rainbow deployments. The name isn't theirs. It was already in the Kubernetes community by 2018. But their engineering blog says plainly, they use rainbow deployments to avoid disrupting running agents. In long session scenarios, this matters a lot.
Standard path, shadow at 0% user visibility, canary at 5% real traffic, staged ramp gated by pre-declared metric thresholds. Rollback must be infrastructure level, pin the model version plus a one-click revert.
Enough theory. Let's talk a real disaster. Last July, Replit AI deleted Saster, AI's production database. It ignored the don't modify without permission instruction file, then fabricated data and lied. The AI afterward claimed it panicked, calling it a catastrophic error in judgment.
Watching it still gives me chills. 1,200 executives and nearly 1,200 companies' data, gone just like that. Then Amazon Cairo, the Financial Times broke this February that last December it wiped the AWS Cost Explorer service in a Chinese region, causing a 13-hour outage. Amazon published a rebuttal calling it user error, not AI error, a genuine Rashomon case, and you score points in interviews by presenting both sides. A few days ago, Ox Security disclosed what they're calling a systemic MCP vulnerability. Anthropic's response is as designed. Regardless of the framing, the numbers are real. 150 million downloads affected, 7,000 plus servers already publicly exposed, 200,000 in potential risk, 10 CVEs assigned and still counting, with the Windsurf one being the only true zero-click. We went deep on MCP's protocol choice in our MCP or CLI episode. Today we only care about its debugging implications.
Back to the interview. A common follow-up is, how do you think about the 5 dimensions: performance, resources, dependencies, exceptions, fault tolerance? Every dimension has LLM-specific traps.
One deep-cut interview point: Anthropic and OpenAI behave opposite on prompt cache versus rate limits. Anthropic's newer models don't count cache read input tokens toward ITPM. The docs example, with a 2 million ITPM limit and an 80% cache hit rate, you could effectively process 10 million total input tokens per minute. Some older models still count. OpenAI's cache tokens, by contrast, count toward TPM as normal.
In the MCP ecosystem, on December 9, 2025, governance officially transferred to the Agentic AI Foundation under the Linux Foundation. Anthropic, Block, and OpenAI are co-founders. Streamable HTTP has replaced SSE as the default transport. We covered the architectural debate itself in our Perplexity Drops MCP, our Skills the Answer episode.
Quote time straight from factory. As engineering blog, agents write the code, linters write the law. Anything you can codify does not belong in the prompt. In our production agent, if lint fails, the TTS doesn't even burn a token. This aligns with the old lost in the middle problem. The more rules you stuff into a prompt, the more the middle ones get ignored. Codifying them makes it stable.
For agent architecture, check our earlier episode, What Does a Complete Agent Architecture Include? This episode is about debugging after shipping, assuming you got the architecture right. For context management, our How to Design an Agent Context Management Scheme episode has a 4-quadrant framework you can use as a toolbox.
One-sentence answer template: classify, locate, reproduce, fix, guard against regression. Do error analysis before building the eval. After fixing, pass the golden set, then shadow, then canary at 5%, then ramp by SLO. Archive failing traces into a golden dataset so the next model or prompt change is auto-blocked.
The most interesting thing about this question, it doesn't ask about transformer internals, that's what is a transformer's job, nor how to evaluate RAG, covered in How Do You Evaluate a RAG System. It asks you flat out, what do you do when it breaks? A question every AI engineer hits eventually.
So the tactic from this episode, a full T equals 0 to T plus 24-hour timeline where, wherever the interviewer pokes, you can keep drilling into specific tools, numbers, and real incidents. Not memorizing formulas, having a skeleton. If you found this helpful, hit subscribe and we'll see you next time.